Hey guys, so today we're gonna see Lead Code weekly contest 487, and I was able to solve two questions under 45 minutes, I think. So yeah, I was not able to solve this question. I don't know how to like this was a system. This is like oops types something. I have to make some classes, and I didn't practice this type of questions that much, and this was a bit tough for me because I didn't learn DP for now. So yeah. So I'll gonna explain the second one because the second one is really interesting. First one is a easy question um like it's something like I think it was a bitwise operator question. Not that much interesting, but the second one was interesting. So let us see. So this was my solution. Before jumping to the solution, let's read the question. It says you're given an integer nums, okay? So integer array num. So we have an array, okay? We have an array A, let's say, and two players are playing, Alice and Bob. Okay, so let's denote Alice with A, Bob with B. So these two players are playing the game. Alice playing first. Okay, very important thing to notice. Alice always gonna play first. So he will always gonna play first. So let's mark it as if. In each turn, the current player choose any subarray nums L are such that R minus L plus 1 less than M, where M is the current length of the array. Overall, they will choose a segment L comma R from the array, and this L comma R value, the segment, the length of that segment. How do we get the length of the segment? R minus L plus 1, as we know. This is the length of that segment, and this value should be less than M, which is current size of the array. Okay, fine, very good. So let's see. Then this the selected subarray is removed. Okay, if we select an array from L to R, from L to R, we have to remove it. We have to remove this subarray, the subsegment from the original array. Okay, and the remaining element are concatenated to form a new array. So the remaining element, all the remaining element will gonna be merged and they will gonna make a new array. Okay. For example, let's take an example for A1, A2, A3, A4, and A5. Okay. Let us say we're gonna choose. I'm gonna take it as one indexing like 1, 2, 3 like this. Okay. So let us say L and R. I'm choosing L as 2, R as um, let us say 4. So I am choosing this 2, 2, 4. 1, 2, 3, 4. Okay. This value is all obviously this length of this should be less than n or m. N is our current array size, right? This value is less than that. You guys can see this is less than this, right? Yes. So we are choosing 2 to 4, and we are removing this from the our original array. So what will gonna be remain? 1 and 5. Yes. These two are remaining. If we remove this, after removing, we're gonna merge this element and this element, whatever here or here. So this is our current element. This is our operation, right? These types of operation we can do as many time as we want to, right? Or one time. Let's see. In each turn, for each turn, we will gonna do this. Okay. The game continue until only one element remains. That means after that we can again remove element. But the thing is, we can't remove these two element. We can't remove these two element because why? Why? We can't choose L this and R this. Why? Because if we choose, that means we are removing this, and we can't remove because this size is not less than the array size. The array size is 1, 2. This size, and we are removing the length r minus l plus 1. So r is 2, 2 minus l, 1, l is 1, 2 minus 1 plus 1. It's like, it will gonna give me 2. So 2 is not less than 2, right? It have to strictly less than 2. This, moreoverly, the size of this array, the size of this array should be greater than the segment. The segment we are choosing is 2. The size is also 2, so it will not gonna work. So we can't choose the whole array. So the conclusion is we can't remove the whole array. We can't choose the segment as our whole array. We have to choose some other. We have to choose at least less than 1. Okay, that's fine. So we can choose either A1 or A5. Okay. So we will gonna remove, let's say we are removing, let's say we are removing A1. Okay. So we have left with A5, right? Yes. So this is our answer. This is our answer. So now what they said, Alice aims to maximize the final element while Bob aims to minimize it. Assuming both play optimally, return the value of the final element. Okay. So we have to return this A5 value. Okay. So if we want Alice to win, the A5 value, the value of A5, we want as maximum as possible. If we want Bob's to win, let's say we are playing this game optimally. Okay. I'm removing this, then I have to removing this. This all are optimal operations. If we want Bob's to win, then we want A5 to be as minimum as possible. Yes. So now how we play, so that L is always gonna choose a subsegment, what after removing that subsegment, the remaining value, the final value is always gonna be as maximum as possible, and Bob will get as minimum as possible. That's the question. Okay, fine. Let's take an example. The examples are pretty much good hint for this problem, right? So it's 1, 2, and 5. So what is the maximum value in this whole array? It's 5, right? It's 5. Yes. So Alice want what Alice want? Alice want the maximum value possible, right? Because it said Alice aims to maximize the final element. So if the final element is 5, then Alice will gonna be very happy because he will gonna win. And if the final value is minimized, it's as minimum as possible, which is what is the minimum value here? 1. Then Bob will gonna be happy. So if the final element is 5, then Alice gonna will be happy. If the final element is 1, then Bob will gonna be happy. Okay, let's see. So let's now try to make an intuition and logic for this problem. Okay. So first turn, as we know, the first turn is always Alice. Alice will gonna play first. Okay. So Alice will gonna come here. What Alice should do so that the final element should be 5 or as maximum as possible. So Alice should always remove the minimum element. Am I right? Alice should always remove the minimum element. So Alice should remove this minimum element because even if Bob remove this 5, because Bob after that obviously Bob will gonna remove this 5. Why? Because Bob wants as minimum possible value. So he will remove this and 2 will gonna be our answer, right? So what Alice wants? He wants the maximum value. So Alice will gonna thought that I'll gonna if for example if Alice remove this 2, then like R and L both are this value, okay? The subsegment is 2 only. Then Bob will gonna remove this 5 and 1, Alice will left with 1 and 1 is the minimum value and Bob is very happy. But Alice doesn't want that. What Alice want? He wants the value uh, to be maximized as possible. If not 5, then the next maximum, which is 2, right? So Alice will gonna remove this. Now Bob left with this. So Bob has no option. If Bob remove this 2, then Alice will gonna be very happy because it's 5, which is the maximum value as possible. But Bob doesn't want that. What Bob wants? The value to be minimized. So Bob will gonna remove this maximum value. Bob will gonna remove this maximum value. and after that Alice will gonna remain with this 2, and 2 is our final answer. Is it right? Yes, it's right. So that's the logic till now. Let's see how can we optimize it. Is there any other cases? Yes, there is. Let's take this 3 and 7 as our example. Okay. So first one is Alice. Alice can remove the whole array. Okay, as we know. So what Alice gonna do? Alice want maximum as possible. So Alice gonna always remove the minimum one, right? If he remove this 3, if he removes this 3, there will be 7 remaining, and yeah, he won. The final answer is 7, and Alice is very happy. And Bob didn't even get a chance to play because yeah, you guys can see this. Because there is only one element left, and that's 7, and Alice will gonna win, and the final element is 7, right? Now, now how do we code this? What is the logic? The logic is very simple. Let me write something. Uh, let us take some random solution, random test case. Okay, 7, 5, 2, 1, 3. Let's say 6 and 8. Okay, let's put here not 8. Let's put here 1 also. So first one is Alice will gonna play for the first time, and he can remove any subsegment, right? So let us say what Alice wants. First of all, we have to thought greedily. Okay, this is a greedy question, so we have to thought greedily. What Alice wants? The maximize the maximum value possible from this array. So what is the maximum value over here? It's 7. It's 7. So what if so Alice wants 7, right? So what if Alice just remove this whole segment? Bob will not get a chance to play, and Alice gonna always win. Oh yeah. We're getting something. We're getting something, right? Getting some logic. Okay. What if Alice choose this segment? No, 1. Bob will be very happy because the answer is as minimum as possible. What if Alice choose? You guys can say, what if Alice choose this? If Alice choose this, is it optimal? We have to play optimally. If Alice chooses, for example, then after that this 1, 2, 3, 4, this 4 value will gonna remain. Bob will gonna see that there is 7 is here. So Bob wants what? Bob wants as minimum as possible. So Bob's first aim to remove this 7. So Bob will gonna remove this value, this segment, and 1 is the answer, and Bob is very happy. So Alice always wants to remove the minimum, and Bob wants to remove the maximum value as possible, right? So we can easily see Alice will not gonna let Bob do this, right? So what Alice gonna do? He'll gonna see that this element is here, so Alice gonna remove this whole segment. Okay. What if I'm saying, what if the maximum element is 8 and it's here? Easy, easy. I is gonna remove this thing, and Bob has no chance to play, and I is gonna win because the number is as maximum as possible. Now, now the thing is, what if so for if our maximum, you guys can see if our maximum is here, the at the edges, then L is gonna always win. And what is the value? What is the value? The value is maximum value. The value is maximum of this array. If the maximum is present at the edges, then the answer is always the maximum. We guys got it. So what if the x? So this is case one, and in case one we are seeing in the edges the maximum values are present. If that's happened, Alice will gonna always win. Alice will gonna always win. And what is the value that what is the final value remaining? It's the maximum value, because if 8 here, Alice gonna remove the whole this segment and remain with this final value, which is the maximum, which is 8. So there is case 2. case 2. Let us write case 2. What if the maximum value is not in the edge? Not in the edge. What if this? For example, mm, in this section, in this test cases, they didn't provide us with that type of um, test. So we have to make it by our own. So let us say the maximum value is 8 still now, and 8 is not in the edge. So 2, 3, 1, 4. Can we say Bob always gonna win now? Can we say that? Bob always gonna win now. Yes, we can, we can. Why? Because the first move is who will gonna play the first move? Alice. What Alice wants? The maximum value as possible. So what his greedily approach? He wants to remove the minimum value from this array. So what is the minimum? This is 1. That's 1, right? So Alice will gonna always remove this 1 because he wants the value to maximum as possible. So if but Alice will never gonna remove this 8 because Alice wants the 8 to be present in this array, right? So he'll gonna remove always the least value. So he'll gonna remove 1, and with 1 he's getting 2 free. So he'll gonna remove this segment. Why 2 free? Because if he removes 2, that's that's doesn't affect our answer because the answer is still 8. Till now the answer is 8. If Alice is gonna remove this for Alice, okay, for Alice this answer is 8. If Alice remove this, the answer for Alice is still 8. Still Alice can get the maximum value which is 8. That's other case Bob now will gonna remove this. But Alice will gonna always remove the minimum. So yeah, he removed this segment. Now Bob left with these three values. So what Bob want? Bob want to be the final answer as minimum as possible. So Bob always want to remove the maximum value, which is 8. So Bob is gonna remove 8. But we know Bob can't remove the whole array, okay? So he have to remove some segment. So if Bob's removing this 8, he can't remove like this because it should be a segment. So Bob can easily remove these two because if Bob only remove, you guys can see if Bob only remove this 8, Alice will gonna take the another Alice will gonna get another chance, and Alice will gonna remove this 3 so that the value is as maximum as possible. That's okay, but what if what if our what if this thing is not 3 4 and rather it's 4 3? So if this is the condition, um, you guys can see if Bob removed this, Alice will gonna remove this 3 always, right? And the value is now the final value is 4 is greater than 3. So Bob gives Alice a chance to maximize the value between 4 and 3 if Bob's only remove it. But Bob doesn't want that. What Bob will gonna do? Bob will gonna remove what Bob wants? Bob wants the value to be minimum as possible. So Bob will gonna remove this whole segment, and now he left with 3. He left with 3. What you guys can see, what if Bob removes this 4 3? If he removes, then Alice will gonna always win. It's very common sense because the value is very maximum. So Bob will gonna, you guys can easily see among these 3, the minimum value is 3. So Bob will gonna remove this segment, and Alice will not get a chance to play. That's the way. Every player wants that the other player don't give don't have a chance to play their move. That's what they want. So you guys can see in the case 2, what is the now what is the logic? What is the can we say that if the maximum value is present in the middle, the maximum value is not present in the edges, then what's the logic? So we guys can see one thing very easily. It's very clear observation. Then Alice will always gonna remove the minimum value, right? And the maximum value is not present in the middle, not present in the edge. Sorry, not present in the edge. It's something in the middle. So Alice will gonna check what is the minimum value, which is here 1. It's present in left side of the maximum value or right side of maximum value. If it's present in left side, Alice will gonna remove each and every element from the left side till the middle element, till the one before index, the from our middle element. And after that, Bob will gonna get the chance, and Bob will gonna remove the maximum value uh, till the before value of our final answer. So if it's present in the left side, then L is gonna remove this. Bob will gonna remove the maximum value, and the answer is this. What if that value, for example, 1 is present here and 3 is present here? Then Alice will gonna remove this. Yes, Bob will gonna always remove this section because Bob can remove the whole array. He have to remove some segment, and if he is getting 8 and 2 is free, right? So he will gonna take the 2, and Alice will gonna get this 3. You guys can say, but Bob can make it 2. No, he can't. He can never. If Bob choose, when will Bob get 2 as a final answer? If Bob choose this 8, and then what will gonna happen? Alice will gonna take the chance, and Alice will gonna remove this 2 always. So the answer is always 3. So Bob don't want Alice to get a chance. So Bob will gonna remove this whole segment, and the answer is 3. So what's the answer? Can you guys see? What's the answer every time? The answer is always the answer is always the maximum value. The maximum value. Can we say the maximum value presented here in the edges? Because the minimum value will gonna always removed by ls, because ls wants the maximum value. So one is always gonna remove by ls. So the maximum value between this and this will gonna be our answer. Can you say that? Which is 3 here. So we have two cases. One, the age is in the maximum value presented in the edges. One, at that time, what will gonna be our answer? The answer will gonna be our maximum value, because Alice gonna remove the whole. Alice will not let Bob getting any chance to play. He will gonna remove whole this segment, right? And the maximum is our answer. But in the case 2, maximum, if maximum is present in the middle, what will be our answer? The maximum value after this 8. The maximum value after this 8. Not, no, 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 I'm wrong. Not after this 8. If there is 7 over here, then answer will also gonna be among this 1 and 3, because you guys can see if ls remove this, Bob will gonna remove this because Bob wants minimum, and this is their answer. So what will be our answer? The maximum value between these two edges, right? That's our answer. You guys can see what I did. Um, I take maximum value of the whole array, and I take minimum value of the whole array. Though I don't think the minimum value is needed. Then what I did, I check. This is case 1, okay? This is case 1. You guys can see. This is case 1. If the maximum value is present in the 0 index and the last index, that means what? The case 1, here or here. If the maximum value presented there, then return the maximum value. It will gonna be our answer. And who will gonna win? Also with that, we can say Alice will gonna always win if this thing happened. And if not, then what will be the answer? If not, that means what? The maximum value is presented in the middle, right? In the middle. If that's so, if the maximum value presented in the middle, then we're gonna compare the value of the edges a0 and a of n minus 1, which is the last value. The first, we're gonna compare the first value and last value. If this value is greater, we're gonna return this. If not, then we're gonna return the last value. Like if one among 1 and 3, if 3 is greater, then we're gonna return 3. If for example 3 is here and 1 is here, if this value is greater, then we're gonna return this. So we just compare, because we can also send the maximum value, like if, like we can also do like this, return maximum, um else what, else we're gonna return the maximum of a of 0 comma a of n minus 1, right? This will also gonna work. What I did here is something which is a wrong logic. I was returning the minimum value if the case I was not able to come up with this case 2 and in the first time, so I only make this case 1 logic, and for case 2 I did something with minimum, but that's not right, obviously you guys can see. So this is their code for this. Bob will gonna win. um yeah, and this solution is submission accepted. And yeah, this is all for this video. I hope you guys like it.